Now, in order to study and probably come out good in image processing, you need certain strengths, skill sets. Now, some of the skill sets, you should be good at linear algebra, you should be good at calculus, you should be good at differential geometry, and of course, you should also be good at the spectral domain, harmonic analysis. You should be able to transform the image from one domain to the other domain. This is the image domain, you have to do some transformation and see this image in a different domain. So when you look at image in a different domain, and possibly there are newer information that are present here from your code. I mean, of course, we are looking at transforms that do not change the modify the image information. Okay, so however, the distribution of image information is only different. So, for example, you also have wavelet transforms extensively used in the last decade. So, to analyze any frequency content of the image. So, frequency content of the image. So, high frequency content, low frequency content. For example, image is smooth image. For example, image is smooth. There's no change in pixel values. Is said to be occupying in a low frequency region. Okay, so low frequency region. For example, if you take a image of a zebra where there are a lot of change in intensity pixel values across x direction or y direction, then you will see that this is said to be some kind of high frequency image. So frequency content of an image. So what we do is we'll do harmonic analysis by taking Fourier or wavelet transforms. So we can able to understand how much this image is containing. What is the frequency range by which the image has. Okay, so some of them are very interesting, right? So